Hello. In this tutorial, we'll discuss calibration of OilWatcher after installation and commissioning. We'll take a look at timing of a grab sample, taking a sample from the sample port for analysis, and adding a calibration point in stable and unstable water modes. Let's take a moment to look at some of the water connections on OilWatcher. From the top, we have the cleaning loop outlet, upper port for manual brush cleaning and pouring in a sample, process water outlet, sample port, the cleaning loop inlet, and the process water inlet, which is below the valve. If this is your first time using OilWatcher, please see the OilWatcher initial settings tutorial linked at the end of this tutorial. Upon initial startup in an application, OilWatcher will require an update to the calibration file in order to bring the readings in line with the oil content in your water. OilWatcher measurements are affected by water properties such as chemicals added to the treatment process, solids and gas bubbles, and flow speeds. If these properties are stable and consistent, stable water mode can be used. If changes to these are expected, unstable water mode is the recommended setting. We'll look at updating the calibration in both of these cases, but first let's look at timing of a grab sample. When oil is detected in the process water, the optimal timing to grab a sample is when the oil content is stable. This is done by waiting for two close readings, taking a sample, and then confirming that the third reading is also close. The light values of the second and third readings can then be averaged for input into the calibration file. With two similar readings, the measurement can now be paused. Here are the readings with concentration, fluorescence intensity, and transmitted light intensity. It's important to determine how close the readings are by seeing a change in fluorescence of less than 1 intensity and a change of transmitted light of less than 2 intensity. We can now grab a sample. Here is the standard 3/8 inch sample port and tubing on all current OilWatcher models. The hand valve can be opened to grab a sample of process water. Please be cautious and open the valve slowly, as high pressure can cause rapid flow from the port. Also, before taking the sample, 1/2 to 1 gallon of water should be discharged from the port in order to clear out any oil or solids that have been deposited within it. The water sample can now be analyzed with OilWatcher benchtop or other lab analysis methods to find the oil and water concentration. After grabbing a sample, Resume can be clicked to take the next reading. We can see that fluorescence and transmitted light intensities are still close between the second and third readings. These values can be averaged for input into the calibration file. After analysis of the oil content has been performed, pause can be clicked and then settings so that we can enter the settings menu and add the calibration point. We'll first look at updating the calibration file for stable water mode. We have our calibration file listed as Texas crude oil, and we'll need to enter running mode to make updates. We select calibration file as the mode and are given the options to start a new file or edit the current file. Let's make a new file. Let's start by adding a calibration file name. We can call this one example stable water calibration.csv. We can then enter the oil concentration found by the OilWatcher benchtop or lab analysis, the averaged fluorescence values from readings 2 and 3, and the averaged transmitted light values also from readings 2 and 3. We can then scale this to the generic calibration data. The file will be scaled example stable water calibration, and we click scale. Select our Texas crude oil calibration file and click open. the calibration file scaled to is the Texas crude oil, and the new calibration file is named Scaled Example Stable Water Calibration. We can now see the calibration file scaled to the detected oil and water concentration, with fluorescence and transmitted light values also scaled. We can now click Save and Use to activate the calibration file, then resume to confirm that the calibration is in place. Now let's look at the settings to update the calibration file for unstable water type. First, we'll change the water type to unstable. Click Save. The water type has been changed to unstable. We'll need both a calibration file and a reference file. Proceed? Yes. Do we want example stable water calibration as the calibration file? No. The calibration file will be Texas crude with solids. Now we must select a reference data file. Texas crude oil.csv for the reference data? Yes. There's a maximum measurable oil concentration of 2008 ppm, which is double the maximum found in the reference file. With water type as unstable, we see our calibration file and our reference file listed. Now we'll go to running mode, and from here we can take a look at our reference data. We'll say no to review the reference data. This is our Texas crude oil calibration with the original values still input, not scaled. We can hit cancel, go back into running mode, and select the calibration file. For this case, we will be creating a new calibration file. We can name this example unstable water calibration.csv. And in this case, we only need to enter the oil concentration found from OWB or lab analysis, the averaged fluorescence values, and the averaged transmitted light values. There is no need to scale this calibration file. After Save and Use, Resume can be clicked to confirm that the calibration file is in place. A new results directory has been generated for this new calibration file. The results file can be found in the results folder located on the desktop of OilWatcher. Data from readings can be found in the results, such as concentration, light values, and temperature. In variable turbidity mode, it's recommended to take water samples when significant changes of oil concentration are seen, and to add any new points to the calibration file. This will allow OilWatcher to accurately detect oil content, even with large fluctuations of solids. Thank you for watching the OilWatcher on-site calibration tutorial. Please visit us at www.clearviewsensing.com for more information on products and technical support. Goodbye.